Hello, hi everyone. Welcome to my channel Unique Physics Teacher. In this video, we are going to understand about the concepts heat and temperature. What is the introduction about the heat and temperature? First, you need to define the heat. The internal kinetic energy due to the random motion of the particles of the matter is known as its heat energy. And when the temperature increases, when any body is heated, the internal kinetic energy increases due to increase in the random motion of the molecular motion and as the temperature increases. Now, how to define the temperature? Temperature is the physical state of the body that decides the direction of flow of the heat. Temperature may be defined as the degree of hotness or the coldness of a body. So two ways we can define the temperature. One is the direction of the flow of the heat. Another one is degree of hotness or the coldness of a body. This is how we can define the heat energy and temperature. Now we can see the what are the SI units for the heat and the temperature. The SI unit of heat is joules that we represented as J and also measured in calories. That 1 calorie is equal to 4.186 joules J, and approximately we can write it as 4.2 joules. SI unit of temperature is Kelvin, and thermometer may be graduated in the following three scales. What are those three scales? One is a Celsius scale, Fahrenheit scale, and Kelvin scale. So for by using these three scales, we can write one formula, that is C divided by 100 equals F minus 32 divided by 180 equals K minus 273.15 divided by 100. For simplify, we are getting the answer for this. C by 5 is equal to F minus 32 divided by 9 equals K minus 273 divided by 5. So this is the formula to find out the different scales. And how to define the heat capacity or the thermal capacity? The heat capacity of a body is the amount of heat energy required to raise its temperature by 1 degree Celsius or 1 Kelvin. So that we call it as heat capacity or thermal capacity. So and it is denoted by the symbol C dash. So C dash is equal to, we can write del Q divided by delta T. So that del Q is the amount of heat supplied and delta T is the rise in the temperature. The its SI unit is joule per Kelvin. Other common units are calorie per degree Celsius or calorie per Kelvin. These are the units for the heat capacity or thermal capacity. The formula is C dash is equal to del Q divided by delta T. Now we can see how to define the specific heat capacity. How to define the specific heat capacity of a substance? It is defined as the amount of heat absorbed or rejected to the change in temperature of the unit mass of it by 1 unit. So that we call it as specific heat capacity. The formula to find out the specific heat capacity is C is equal to 1 by m is the mass and del Q divided by delta T. The unit of specific heat is joule per kg Kelvin or calorie per gram degree Celsius. Here it will depend on three factors. One is the nature of the material and initial temperature of the temperature interval and the process of condition under the heat transfer takes place. These are the three factors. It will depend on the specific heat capacity. Now we can define the molar specific heat capacity. How to define the molar specific heat capacity? It is defined as the amount of heat absorbed or rejected to the change the temperature of 1 mole of it by 1 unit. The formula is C is equal to 1 by n times del Q divided by delta T. So this is the formula to find out the in terms of molar specific heat capacity, that is C is equal to 1 by n times del Q divided by delta T. What is the unit for the molar specific heat capacity? That is joule per mole degree Celsius or calorie per mole degree Celsius. So these are the units for the molar specific heat capacity. And the formula is C is equal to 1 by N times del Q divided by delta T. This is the formula specific heat is capacity. Now we can see the sum of the substance at room temperature and the atmospheric temperature. What is the specific heat capacity? Here we can observe aluminum is 900, carbon 506, copper 386, lead 127, silver 236, tungsten 134, and the water 4186, and ice is 2060, glass is 840, iron is 450, and kerosene is 2118, and edible oil is 1965, and the mercury is 140. You observe here the water, it will be having the specific heat capacity will be more. That value is 4186 joule per kg per Kelvin. So that is the highest value, and the lowest value is mercury, that will be 140 joule kg Kelvin. So now how to derive the relation between the heat capacity and the specific heat capacity. Let del Q of the AD be supplied of the substance, and the mass we considered M, and the temperature increase we can consider as delta T. Now the specific heat capacity formula C is equal to 1 by M times del Q divided by delta T. Now we already know how to define the heat capacity, that is C dash is equal to del Q divided by delta T. Now substitute in the above relation, that is C is equal to specific heat capacity is equal to heat capacity divided by M. So we can rearrange the equation. We are getting one formula, that is heat capacity is equal to specific heat into mass of the substance. What is the final relation? Heat capacity equals specific heat into mass of a substance. That is the relation between heat capacity and specific heat capacity. Now we see the diagram. So this diagram represents the calorimeter. Now we need to understand here one topic, that is principle of mixtures or the principle of calorimetry. So what is the calorimeter? It is a device in which heat measured can be made. Heat can be measured in calorimeter, and the temperature can be measured in the thermometer. You observe the diagram. What are the parts they are given? Stirrer they are given to mix the liquid properly, and one like protector, that is poor conductor, and the polished copper vessel, and we can use the thermometer to see the temperature. Objects at different temperatures are made to come in contact with each other in the calorimeter. Consequently, heat is exchanged among the objects themselves along with the calorimeter. You observe this, and when heat flows occurs between the two bodies that are isolated from their surroundings, there is no contact between anything into the surroundings. The amount of heat lost by one body must be equal to the amount of heat by the other. So that is, we can write it as heat lost by the body at higher temperature is equal to the heat gained by the other body at lower temperature. Both will be equal. Here we can write it as M1 C1 times T1 minus T equals M2 C2 times T minus T2. Here heat is a energy is transit, so the principle of calorimetry is actually a conservation of energy. And conservation of energy means energy neither be created nor be destroyed. It can only change from one form to the another form. Here match the following they are given. Choose the correct option. Heat capacity SI unit is what? Joule per Kelvin, and specific heat capacity is joule per kg Kelvin, and molar specific heat capacity is joule per mole for degree Celsius, and the heat is joules. The correct option for this question is option number 3 is the correct answer. Just choose the SI units, correct SI units. You observe here, and another question. Specific heat capacity is maximum for specific heat capacity is maximum for where? Water. We already discussed. And the thermal capacity of 100 gram of aluminum and specific heat they are given. Just you multiply. We already know the relation. heat capacity is equal to 100 into zero point 0.2. We are getting the answer 20 calorie per degree Celsius. That is the answer for this question. And select the correct statement related to heat. Here what they are given, you eliminate the options whether it is correct or wrong. Heat is possessed by a body. Obviously it's correct. And hot water contains more heat compared to a cold water. This is also true. And heat is an energy which flows due to the temperature difference. This is also correct. Means all what the options they are given, all should be correct. And what is the another question? Temperature is a measure of what? Hotness or a coldness of the body, that we already discussed first initial itself. Temperature is a measure of hotness or the coldness of the body. And the SI unit of heat and the temperature, this also we discussed the starting lesson. That is SI unit of heat is joules and the temperature is Kelvin, and the other units for the temperature is degree Celsius and degree Fahrenheit. So these are the few questions related to the topics. And what we discussed so far, we discussed about the first is heat energy, and another one is the temperature, and the relation between the three scales, that is Celsius scale, Fahrenheit scale, and the Kelvin scale. And also we discussed about the heat capacity. Heat capacity of a body is amount of heat energy required to raise its temperature by 1 degree Celsius or 1 Kelvin. So that is heat capacity. And also we discussed about the specific heat capacity of a substance, that is defined as the amount of heat absorbed or rejected that change the temperature of unit mass by 1 unit. And also we discussed the relation between the heat capacity is equal to specific heat times the mass of the substance. And also we discussed about the principle of mixture or the principle of calorimeter. Heat lost by the body at higher temperature is equal to heat gained by the body at lower temperature. So thank you for watching my video. Please like, share, subscribe for more videos, and don't miss the next class. Thank you.